1926, we are given a scenario where we have a wire that has a length and it's carrying a current of 2 amps. We're told that it has mass per unit length of 0.5 gram per centimeter. So what that means is this is mass over length. That's what this is. It's a density, right? Okay, so we want to know, this has a current, we want to know what is the minimum magnetic force that we can get to actually lift this wire off of the ground. We're also told that this is the southward direction. The current is moving southward, and we want to know what is the minimum direction and magnitude of the B field that gives us a magnetic force that lifts this thing off the ground. Okay, so now, so for the minimum, what we want to know, we pretty much need something to be in equilibrium, right? So this is going to be the magnetic force. We're just drawing our little diagram here. This would be the weight force that we have to overcome to lift this off of the ground. There's going to be some angle. There's going to be some angle that the B field makes with the wire, but we want to make sure that this is going to be 90 degrees because we want this thing to lift straight off the ground, right? So what does that mean? That means that the sum of our forces is going to be 0. We're in equilibrium. To find the minimum, to find the bare minimum that we can of the magnetic force just to get this thing off the ground, right? So okay, what do we have here? We have B times the current times the length of the wire times sine of the angle that the B field makes. This is our force minus mg, right? These forces are in opposition as far as the direction. And so now we have B times I times L times sine of the angle is equal to mg. Well, we don't know the length of the wire, we don't know the mass of the wire, but we do know something that was given to us earlier. B times I times sine of the angle is equal to m over L. I'm just taking L to the other side, and now this is something that we've seen before. In fact, it was the first thing we were given. So B, we'll call this B min, is equal to m over L times G times 1 over I. And we're going to assume that the angle is 90 degrees. Okay, so that's 0.5 grams per centimeter times 9.8 meters per second squared times 1 over, what was the current? 2 amps. 2 amps. We need conversions, right? We are in grams, centimeters. These are not SI units. So now let's put in some conversion factors. So 0.5, we'll just put all the numbers. 1 over 2, amps is fine. Meters per second squared, that's fine. Times grams per centimeter. Okay, now we need to convert to kilograms. So we have 1 kilogram per 10 to the 3 grams, right? So that'll knock that out. And then we have 100 centimeters per 1 meter. So that knocks that out. And now we're in SI, right? So now we have a value of about, putting all this in, we have 0.245 Tesla. That's the minimum B field that would be required to lift this wire straight off the ground. Now the direction, since the force is upwards, the current is southwards, we would have F cross I, right? So this is going to be right hand, fingers straight up, and then curl this direction. which means that the B field would be pointing, actually, sorry, it'd be pointing that way, right? So we right hand fingers this way, curl that way, makes your thumb point into the page, which is eastward. So our B field, 0.245 Tesla eastward direction.